Hi everyone. This video we are going to complete the hands-on exercise on week number 2 regarding the Wireshark, using Wireshark to show the ARP and also the frame forwarding technical details. ARP stands for Address Resolution Protocol. It's been used to find out the MAC address that's needed to send the frame out. When we say frame, we are focused on the OSI model layer 2, the data link layer. And for the same data unit, if we use packet, then we are focused on the layer 3 regarding the IP layer. So we're going to open this document and follow the information here to complete with this video. First thing first, we have to remotely sign on to MonSec using the VMware Horizon to connect, to do the hands-on. So we are going to use the Horizon VMware client. Previous week, we have shown how to install this Horizon client. So you double click that. And when it is running, make sure you click the heavier.monsec.edu. And this is your username for the Monsec account. So usually it's the same as the one that you use for the Canvas. And make sure the domain it's remain at the Monsec, MSec, okay? And the password, that's your password and your username, okay? And once connected, let's wait for it to come up. And I'm going to put this in the background. Well, while it's coming up, let's continue on to talk about this regarding this document that we're going to use the video for. The objective for this particular topic is to illustrate, to review the frame forwarding process with the focus on the OSI layer 2 model. The main objective is to use the Wireshark to capture the packet while you're communicating at the same network. When the source and destination host, they are on the same network, we try to find out what's in the source and destination MAC address field on the ICMP packet or frame one referred to. When you ping a different network, for instance, if you ping Google from your home or from the lab, what would the destination MAC address be? And to understand this is to prepare us to better understand the man-in-the-middle attack exercises later. And we are going to, throughout the course, we are going to craft the packet to send the packet from outside to the target. Knowing the communication in the layer 2 will facilitate us to put into the correct destination of the MAC address to make the exercise successful and to make the understanding of how to do the vulnerability assessment, do the pen testing, and to protect your network more effective. So that's the purpose. The layout of the lab, we have briefly went over this week ago. All those are the images. When we run the Horizon client, we are able to access it remotely to access those images to complete our lab. In this lab, we're going to use Windows 2012 and Windows 10 as the inside to inside. So the procedure we're going to follow later actually calls for, let's power on the Windows 2012, then the IP is 10.01.12 pre-configured, and you're going to power on Windows 10. So we're going to ping each other, and you will capture the packet and find out, hey, because it's from local to local, you are on the same network, then you are going to use the true MAC address. If 2012 is pinging Windows 10, then the destination MAC address will be the true address of the Windows 10's MAC address. If Windows 2012 or any of the internal hosts here try to ping Windows 2016 at different network, which is 10.10.10.16, then just by looking at the logic, you are going to send the communication, either call it packet or frame, because it's going to be routed through it. So it'd be more appropriate to say, hey, that packet has to go through the router. We power on a router here, and you're supposed to send that to the router, and the router will forward it to destination to Windows 2016, or to your default gateway of Internet FW and go to the Google if we ping Google 8.8.8.8. So that's the logic. It has to flow that way. Therefore, the technology is designed in such a way that if you try to ping IP address not on your network, you are going to put your default gateway, okay, their MAC address into your destination. So therefore, so when you send it to the switch look at it. Switch usually is a layer 2 product. It doesn't understand anything else. It just look at the MAC address. So when you send a frame over to a switch, it look at the first 6 bytes, say, hey, destination. Oh, that's the MAC address of, well, it didn't know. It just compared the port. Once it find a match, then it will forward it out through that port. So if you try to ping outside of your network, it's the sending computer's job to put the default gateway's MAC address in your frame. So when the frame send it to the switch compare that and say, oh, this port number, whatever number is connected to the default gateway. It doesn't even know that's your default gateway. It will just forward the packet to the default gateway. And the default gateway will look at it and say, hey, oh yeah, it matched my MAC address. Yeah, let me look at it. What IP do you want to talk to? It's not me. You want to talk to someone else. And usually the computer will drop it. However, it's a router, so its job is to forward it for us. Therefore, it's going to do exactly what you did here in 2012, try to ping 2016 or ping 8888. This box, whether it's a pfSense or ASA, it's going to look at it and say, hey, oh, destination, which is 10.10.10.16. Well, then if it's the same network, then I'm going to use 2016's MAC address in the packet that I reassemble for you and send it out for you. And the switch here, again, receive your frame and looking at the layer 2 information, destination, oh, it matched Windows 2016. Then it's going to forward it out from this port. Switch doesn't know what you want to do, nor does it care. It just match the MAC address on the destination and compare with the table and send it out. And then Windows 2016 received it. If it's configured in such a way that it's going to respond it, then it's going to do exactly what you did and see who sent it out. Oh, well, 10.01.12. Is it on the same network? No, it's not on the same network. Therefore, I'm going to go ahead and send it to my default gateway. Okay. Of course, in our case here, sometimes we'll do NET or PAT. So therefore, the router or the firewall is going to replace and hide your original 10.01.12 and using its IP to send it out. But it doesn't matter. Instead of send it to 10.01.12, it will, the destination of 2016, it will send it back to the sender, which is the default gateway of the internal network. So then packet will send back through the same logic. If it's go to Google that you want to ping, then this default gateway is going to look at it and say, am I directly connected to Google? No, then I'm going to send it to my default gateway just as the other host did. So therefore, you're going to reassemble the packet and put in the destination MAC address of the default gateway, which is Internet FW. The MAC address will be sent into the ICMP packet here. And so that frame going to the Ethernet layer 2 device, it's going to look at the destination MAC address, which your system, the ASAV or PFSense, they put in the Internet FW's MAC address in there. And the switch doesn't even care and doesn't even know what you want to do. It just try to compare that and look at the MAC address there. It's just going to forward it to Internet FW. And the process going on and on and on and reach the destination with the same process sending back. So let's just summarize it a little bit, is that if from local to ping to local, you were going to use the true MAC address to communicate in a layer 2 sense. If you try to ping or communicate with any host that's not on your network, even if it's right next to you, or it's a couple 100,000 miles away, it's the same way. You are going to use your default gateway's MAC address as the destination and send it to the switch so that the packet can be routed to the destination host. And it has been summarized in our discussion and sample posting as well. So before we dig into the hands-on, I'll give you a top overview. First, we'll follow the step here, power on the system and do the exercise. And we're going to capture it and then verify the idea that I just went through to show the MAC address of the ARP response or the communication there to verify that the communication is on the same network. Okay, so when we communicate on the same network, that's the first step we try to verify. And then we'll ask the question, hey, the MAC address, what's the destination? Does it match the real one? Actually, yes. And then the detailed answer and discussion is in the discussion board sample posting. Okay. And after this first part, then we are going to, of course, power on additional default gateway and Windows 2016 and other different network. So once we power on Internet FW and power on PFSense.net, then we actually power on the PFSense.net here. We power on the internet. So the 2012, it can actually go through your PFSense. In this exercise, we use PFSense. Then it can be able to ping Windows 2016, which we will also turn it on, and we can go through the internet firewall to ping the Google. That's what I just explained a few minutes ago. So once we power on those, then we will clear the ARP cache. Just make sure that there's no more whatever cache in there as if it's from scratch from beginning. Then we're going to ping the host at a different network. Okay, different networks such as you ping the 8.8.8 or you ping the outside Windows 2016. Then we're going to capture and doing the same thing and verify, well, what's the MAC address? Does it belong to? It's actually the default gateways. And the detailed explanation, again, has been posted on the DB as a sample posting. And then we already did discuss the detail of the same network when you try to communicate to the host at the same network, or you try to communicate with the host at a different network. And again, the detailed discussion, in addition to what I just explained in this video, it's been written down in the sample posting. So feel free to take a look at that. And this will be related to the discussion board that we are required to do discussion and get the credit for. All right. Let's go back to the VMware Horizon client. Once you sign on to the Mosaic network, then it's going to come up with this image here, say, hey, you want to log in as a student. And you are going to say yes. So you just go ahead and click it. No password, nothing. Just go ahead and click the right arrow. And then you will log in to one of the software image at Mosaic. while it's loading, so then what we're going to do is doing the first exercise. What we will do is we will power on Windows 2012 and Windows 10, and then we are going to go ahead and complete the first exercise, step number 1, 2, and 3. So if you want to open this document, you can actually open it and follow along with the exercise. So this is the remote host that we are going to complete our exercise. The VMware workstation, you can double click that and make sure it's working. It takes some time, so just make sure that it doesn't have multiple instances running. So just want to make sure that we had only one instances. It's very common sometimes. You say, hey, it's not coming up, just keep clicking. So just make sure that we have only one instances running on a taskbar. So now we were going to highlight, and you can see that this is very similar to what we just explained in my document on the layout. So this is the internet firewall connected the whole network to the internet, and this 2NIC card system is the gateway or the firewall connected to the outside, and then one interface connected to the inside client. And our inside is 10.01, outside is 10.10.10. Okay, so you're going to highlight 2012, and it's going to ask you, okay, it's going to ask you if you want to take ownership. Just say yes, you want to take it. Okay. And then you highlight window 10. It's going to ask you the same thing. You just make sure that we take care of this first. All right. And sometimes you have to give it a few seconds or minutes for it to pop that up. Otherwise, it may ask you, do you want to remove it? If you accidentally remove it, no problem. Just go ahead and click on here, window, right click, and then in the shutdown or sign out, you cannot shut down. We don't want you to shut down either. Don't disconnect and just sign out. When you sign out and you sign back in, it's reset to the original stage. When it's disconnected, that means you want to save your current work at least for about 30 minutes, depends on how much set up the resources. So you can leave for a while and come back, and hopefully everything's still there for you. So I don't recommend doing this. Once you go in and finish the exercise and sign up. Okay, so that's just the overhead. I like to cover it in the first video. Right click here. I have a few snapshots. This is a snapshot manager you can do, but at this time we don't have to do anything else, so I'm not going to mention too much about that. You are going to click that, and then there is a power on. Right click, okay, and then we can say start a guest. It's going to ask you, what did you do with it? You're going to say, hey, I moved it, okay? Don't say I copied it. When you say I moved it, it's going to keep the MAC address. So whatever I did in my exercise in the video here, it will be identical to the one that you do if you follow along. But if you say you copy it, then in here, if you say I copied it here, then you will be generating a new randomized MAC address. Then if you try to compare your result and my demo, it wouldn't be the same. Okay. Okay, so let's go to the Windows 2012. Well, give it a few minutes to boot up. So you're going to right click on this box, and then you're going to say, hey, send the control alternate delete here. Click that. It will be here. And the password has been listed on your on the canvas. I apologize for that. Let me just stop my recording. Sorry about the interruption. So right click here. We are going to go control alternate delete. Send the password, send the login prompt, and the password is change me, CHANG. Got it. make sure you click it again here, CHANGEME. So this is sign on to it. And some basic maintenance on that is you can exit out of the server manager here. And then here is the quick icon. You can access the property of your network. For those who you're not familiar with it, you can right click and then go to the Open Network and Share Center here and go to the Change Adapter Settings. And you can see there's only one internet because it's the inside. And if you highlight it, right click and take a look at the property here, and look at the IPv4 address. It's been set to 10.01.12. Our default gateway is the pfSense 10.01.1. The DNS server, which we're not going to use for now. So nothing needs to be changed to complete this exercise. Now we are going to go into the Windows 10 as well. So right clicked, and now let's do Control Alternate Delete to it. And again, you have to click it once so that the focus will be in here, CHANGEME. Now in here, it's the same way. You can actually take a look at that. Or another way, we have to do that anyways. So highlight in here, like you can just run the CMD command. So here, left click on that, you can quickly access the prompt and IP config. So then it's 10.01.210. So internally it's 210. So another command is called ARP. And if you just hit enter, it tells you, hey, you have so many parameters you can use. What we will do is we're going to do ARP-A. So what's in the address? If you do an ARP-C, it's going to -D is going to delete it, so we can see that. Now we can ping in 10. This is a little bit off our document. Just give you a heads up on the command. 10.0.1.12 because I know that's the 2012 IP. So once you ping that, it's successful. Okay, and we're going to verify the MAC address later. But in this case, after you have done the ping, if you do up arrow key twice, you can see ARP again. So if we do that and make it bigger, so you can see that. You can see now, okay, 10.01.2. After you communicate with it, you can see that the MAC address is now in your cache. So you can take a note on that. So it's a C1217F. Okay, so this is the 2012 MAC address. All right. So it's plugging in with the Windows firewall. If I turn it on, then our exercise won't be successful because you are not going to respond to the ping. It's making it difficult. So that's why it's been turned off intentionally for the simplicity's sake for the exercise. Okay, so now you can see it's been cached. If we wanted to clear the cache, what we will do is we'll do ARP-D. And after you've done that, and if you do an ARP-A again, so you can see that, oh, okay, now it's cleared up a lot other than just a few of the static ones that remain here. So then we can, if we redo the exercise, then we can see, hey, this is the R packet. The reason why we need to learn how to clear is because if you already have the dynamic MAC address it's been cached for the host that you want to communicate, it's already been dynamically cached in. It wouldn't do an ARP to request that again. So then once you can ping, the first time, if you don't have the MAC address, it's going to do an ARP to request the MAC address. Once you have that, it's no longer going to send out any ARP. Then you can ping as much as we want. You just won't be able to capture any more of this ARP packet. Okay. All right. That being said, let's go to the 2012, and then in this case, we can drag it down a little bit on the right-hand side to see the whole thing. unless you want to use the full screen. In here, you can right click. The setting is slightly different. Windows 10, you left click to see the command prompt easily, and right click in the 2012, you can actually go to the command prompt quickly here. There are many other different ways, but just I think the left click, right click on the window icon is much easier. So now if you do the same thing, ARP-A, and you see, hey, 210 is already in here. So if I ping 210, I wouldn't be able to capture the R packet because it's in there. So when the Windows 10 the 210 talk to the 12, not only 10 will acquire the MAC address of the destination, but also the 2012 will keep a MAC address of the Windows 10s, right? So that's E9, E9 F4. So we keep that in mind. Put it on the side. Now we may be able to see. We may need it again, but in this case, we gotta delete it and make sure that it's no longer there. All right. So we are gonna run the Wireshark in here. Okay, once we started it, and now we are going to ping 10.0.1.2 ping. We're going to ping that. All right, and now we go here and then we stop it. So once we stop it, you can see, oh, I got quite a few packets in here, all right? So in here, let me just enlarge it. It's easier to see that. Well, I got quite a few of those information here. So we're going to clean it up a little bit. Okay, so if you put in the filter, put in ARP or ICMP, and you hit enter key in there, then you're going to filter out all the unwanted information other than the ICMP or the ARP packet here. So now in here, this is ourselves, or this is one of the box in here. It's going to say, hey, who has a 10.01.3? So this is basically tell Windows tell the 10.01.12. So we know this is ourselves. We are at Windows 2012. We send out quite a few ARP. We're going to ask DNS or default gateway. What is your MAC address? Let me know. I want to know it. So those are the ARP. And when we ping from 10.01.12 and try to ping the 210 Windows 10 address, before we can complete that, we need to acquire MAC address of the destination, which is on the same network. So then in here, the first one in here, right above it, it will say, hey, broadcast. And this is called ARP request. And say, hey, who has the 1.210? Because that's what I'm going to ping you, right? And what is your MAC address? Tell me that, ARP. So it's a request. And then the 10.01.210 is responded reply and say, hey, I am at F2E9 F4, and that's me. That's my address. Now, if you take a look at the command prompt icon here, before we clear it, and you can see that, hey, it's at F2E9 F4, and you can see F2E9 F4, which is right here. F2 it is at F2E9 F4. So it's a reply. So don't be confused. When the Windows 10 reply, it's going to use it as a source address. Okay. I'm telling you I'm here, but in the reply, if you take a look at it in the Ethernet here, and if you take a look at this one, the source itself, this is the Windows 10, because they are sending it to you as a reply. Therefore, they're putting their MAC address as the source. And the destination will be C2217F, which will be the sending host, Windows 210, Windows 2012, your MAC address. Okay. So in the reply packet, the destination will be, the original requesting the Windows 2012 MAC address, and the source will be, of course, the reply host Windows 10's MAC address into. But in any case, it's a reply to tell you that, hey, my MAC address is in here. And after that, the next packet in it, if we click on the next one. So if we take a look at the next one, once the Windows 2012 receive the MAC address from the Windows 10, then it's going to say, hey, I can now ping you now. So therefore, it becomes an ICMP packet in here, so you can see. And look at the source and destination. I'm the one who is sending it, and this is my MAC address, not a problem. But you told me that your MAC address is this one. Therefore, I will put it as a destination. Therefore, I can actually complete my ICMP request and send it out to communicate, and you would reply it back. So that's a communication from a layer 2's perspective, important perspective, important fact that even on the same network, you have to use the true host MAC address to actually communicate. That's why we say MAC address only locally significant, because you will never use the MAC address that belong to a host that's not on your same network. It will never reach it. Your switch will know that. Your switch layer 2 locally here connected to all the hosts locally, and then cache all the MAC address there for you to communicate locally on a same network. So now we are going to continue on. Let me just exit a lot of it, and we can quit without saving here. Now we are going to complete this part of the exercise by going to turn on the Windows 2016. You highlight it there, and you're going to say yes. You are going to take over the ownership, and we use pfSense next. So click here. Now we have to say the same thing. Take the ownership, and we are going to do the infinite firewall. So we have to do the same thing. And now I clicked, we can say, hey, I wanted to start up the guest, and I moved it. And on the Windows 2016, right clicked, and we're going to start a guest, and you say, yeah, I moved it. And then we also have a pfSense here. Yeah. pfSense net, I clicked, start a guest, and I moved it. So this is exactly documented on the procedure for the document on page 2, step number 4. Now we're going to go to Windows 10. At this time, while it's booting up, we go to Windows 10. And if you do another ARP -A, and you're going to see that, hey, I do have Windows 2012. Yeah, Windows 2012 is actually 21.7F. Yeah. And if you want to check your own MAC address, you can do ipconfig/all. So if you do that, and you can see that, hey, my MAC address here, yeah, F2E9F4, so which is exactly the correct one, right? So this one will be used as the sender now. We are going to reverse it. We're going to ping from this one, the E9F4. We're going to use that to ping Windows 2000. We're going to ping either Windows 2016, or we're going to ping the Google 8.8.8.8. So at this point, we are going to do an ARP SD. So we can delete all of them. And of course, we are going to have to run. Oops. accidentally close it. Okay, so if you click the window icon here, and W is at the end here, this is the Wireshark. Just go and click that, get it to running. You can remind it later because we're not going to update it. Okay, so once you see that Wireshark here, go ahead and highlight here and double click. So it starts to capture it. And let's go ahead and ping 8.8.8.8 at this point. So we do that, and you can see that they captured the 8.8.8. Now we can stop it. Let's take a look at it. You see, we have ICMP, but we didn't capture any of those ARP packets. So we do an ARP-8 address. And you can see that because it already happens. You see the 44, 3844, 10.011. That's the default gateway of the internal one. See, this two internal gateway is the pfSense, which is 10.0.1.1. So if you take a look at this topology again, you can see that those are 10.0.1.1. And so either the Windows 2012 or Windows 10, the default gateway is 10.0.1.1. And if you already have the MAC address here, then you weren't doing ARP. So therefore, what we want to do is we can actually, in here, we can do an ARP-D again, and then make sure that's not there, and then we just ping it again. So now, if we come here, oh, we forgot to start it again. So I'm going to start it again, and I'm not going to do it. So again, we're going to duplicate that, delete it, and ping it. This time, I think I got it. So let's just stop and take a look at it. Again, in here, we're going to see ARP or ICMP, right? Oops, I can type it. So now you can see that if you filter out everything and just see the R packet and ICMP packet, you can see that, hey, this is an ARP. Highlight first one is this ARP request. From who? From me, E9F4, and say, hey, where's my default gateway? Give me your MAC address. And the default gateway address here, the 44, this is the default gateway. And it's talking to me, the F4, that's me. See, E9F4, that's me. That's a Windows 10. So the default gateway telling me that, hey, I am here. And this is a reply. And of course, we are on the same network, right? Yeah, so, and I will give you the default gateway's MAC address. And then later on, so when you try to go to Google, when do an ICMP request, you are going to put in my MAC address, the 3844, as a destination instead of Google's MAC address, which is meaningless. So if you click that one, you can see that, hey, destination, you can see that, hey, yeah, destination is actually the default gateways, F2, E9, F4, okay? So, and of course, when they replied back, when Google replied back, my router, my pfSense in this case, is going to use its MAC address, right? Its MAC address is the source. I'm the default gateway, and I receive a reply back from Google, and I'm giving back to you. So that's the communication from the local network to a remote network, whether the remote network is just right next to it or at Google a couple thousand miles away. It's the same process. So let me just put this document back up here. So from Windows 10, what we did is we cleared the ARP cache, and we actually run Wireshark to capture it. And we can ping the host Google, which is what I just did for the 2016 if you want to do that. Then you stop the Wireshark, and then you put a filter in to show us ARP and also the ICMP packet. Then you can see that you see, find and paste a screenshot, which in your discussion board to show the MAC address of ARP response, the reply. And of course, the reply will be using the MAC address of the default gateway is going to tell you what its MAC address is, as I just showed you in the video. And does the MAC address in the screenshot show the MAC address of the remote target host? No, of course not. It's showing the default gateway's MAC address. Okay, and the detailed discussion has been written down in the DB sample posting. So now you should know the differences between if you communicate in the same network as opposed to if you want to communicate to the remote network. It's important to know that because later on when we do the vulnerability assessment, we are going from outside to go through the firewall and to do a pen testing to the internal host. And you have crafted, we will craft a packet. Say we craft a Slimer attack, then you have to direct the packet instead of sending it out to the internet, which we never want to do it. We have to actually craft it and put the correct MAC address into our crafted packet. And so it will be sent to the correct host and being forwarded to our victim target. And then we can complete the exercise and better understand how to do the pen testing and how to perform the defense. Yeah, whether it's on the internet, cloud-based or local-based, it's exactly the same concept. Yeah. This completes the exercise. But before we go, I would like to show you what do I mean by the discussion board. So if we go back to week number 2, and this is the document that I just showed you, and it's related to this video. And there's a discussion board that's related to this video regarding the same network, different network ARP process in there. And here is what I mean, the sample posting. So if you click that, and you will see each title and with the screenshot, and then with the discussion. In my document, I will ask you to read the detail, which I also explained in this video. Okay. And this is the end of our recording. Thank you.